My name is Manuel Amunatigi, and I've been a data scientist in the healthcare industry for the past 5 years. Before that, I was a quantitative developer on Wall Street, and before that, a web developer for many years, including 4 at Microsoft. One of the challenges I've faced at all my jobs has been finding clever ways of dealing with large data. This seems to be a timeless question. Even though the size of the data has changed through the years, we always seem to have more than can fit on a single machine. We start by asking ourselves questions like, is it even worth going through all the trouble to process this data? Or maybe I could get away by taking the n top rows or a random sample of the data. One workaround I've often used is to break the data into chunks and process it one chunk at a time sequentially. So basically, I would fire up my machine, kick off the script, and literally come back 2 weeks afterwards with my fingers crossed, hoping that the machine did not crash and the data was processed. Thankfully, today, we have quite a few tools to help us address those exact problems. The more famous one that came out maybe 5, 6 years ago is called Hadoop. Hadoop allows you to spread your data onto many machines using a process called MapReduce to reduce that data onto a smaller set of machines and keep doing that until it fits on a single machine, until the aggregate information that you want is there on a single machine, and then you can work off of it. Spark came after Hadoop a few years afterwards and took the best aspects, the best features of Hadoop and made it even better. And if you go to spark.apache.org or the official website, there's an interesting chart that shows you the processing time difference between Hadoop and Spark. Because Spark can access distributed live memory, not just hard drive space, it can be, as it states, 100 times faster than Hadoop MapReduce. So there's definitely a huge gain in speed by using Spark. And another aspect I really like about Spark is Hadoop. You have to use a language called Pig in order to do MapReduce. And there are a few other languages you can use, but that's the main one. Spark, you can use off the shelf languages like Java, Scala, Python. You can even use SQL queries to run your Spark clusters. And of course, you can use R, right? This is the topic of this class. Spark R is a latecomer to the Spark Apache package. Came in, it was introduced as of version 1.4, and we're currently at version 2.0, but it is catching up quickly. A few more points before I end this introduction. We're going to be building our clusters using AWS, Amazon Web Services. So you will need an account in order to create your clusters. Another point of importance is we are going to be creating our clusters, doing all that work manually by hand. We're not going to be using a simulation tool, and we're not going to be using a third-party cluster management tool. We will be looking at a good one in a later lecture, one I like to use as well. But overall, we're going to be doing everything from scratch ourselves because that is imperative to truly learn how to program for cluster computing, right? For parallel computing. You don't program like you would normally program in R on your computer. You have to program in a way that you're constantly thinking in the back of your mind, this is going to be broken into chunks onto many different computers. So the paradigm is different, and it's important to understand that. The quicker you understand that, and one way of quickly understanding it is building your own clusters, the quicker you'll be able to make use of this. The other thing is AWS clusters aren't free. It can be cheap, it can be expensive depending on how many clusters you use and for how long you're running them. We're going to be keeping the cost really low. We're going to be using the most basic clusters, and we're only going to be using them for a few hours. I think a cluster per hour, depending on your region and the time of the day, is around 5 cents per hour. So it's very cheap. It's not going to cost you a lot of money. And I will constantly remind you to stop your clusters and terminate them or destroy them when need be. And that way, Amazon stops charging you. So it's very important. I'll keep reminding you that. By learning Spark, you will take R to a whole new level. Finally, you won't be limited by the size of your machine, the amount of memory you have, the amount of hard drive you have. You will be able to virtually do unlimited amounts of data. And that, I think, is a great way of extending your R skills to today's challenges, basically dealing with very large, big data.